Okay, thank you, Session Chair. Hi, good day, everyone. My name is Noorsuhada from Civil Engineering Studies, College of Engineering, University Technology Mara, Penang Branch, Malaysia. Today, I would like to present the topic on the behavior of one hollow interlocking block. Okay, the behavior of one hollow interlocking block made from recycled concrete aggregate under flexible loading. Okay, this one is my presentation outlines. The first is motivation, and then objective, experimental program, results and discussion, and lastly is the conclusion. Okay, as we know, if you refer to this construction waste, most of the world's daily solid waste is attributed to the construction industry, with concrete waste making up a significant proportion of this waste. The construction waste increase every year and has a negative impact on the environment and causes social problems in the surrounding communities. And if you refer to this Malay Mail 2023, okay, based on this news, February 2023, this year, the construction waste is estimated to be about 27,068.4 tons, with concrete and aggregate waste accounting for the largest share of 17,820 tons, or 65.8% of the total construction waste generated. It is increasing every year as 326 tons of construction waste was disposed of in illegal dump site in Kuala Lumpur only, okay, which accounted for 94.6% of the total illegal waste generation of 344.3 tons in the city. Therefore, it is very important to manage and reduce the amount of construction waste generated by adopting sustainable waste management practices such as waste reduction, reuse, and recycling. Okay, so in this case, we prefer to reuse the material rather than we dispose to dump site, where the crushing of concrete waste from construction and demolition waste has proven be a successful method for obtaining recycled concrete aggregate. This recycled concrete aggregate can be used as a substitute for natural aggregate in the production of new concrete, resulting in the production of recycled concrete aggregate. From the review, found that the strength of the material or structure containing recycled concrete aggregate reduces as the percentage of recycled concrete aggregate increase. Although recycled concrete aggregate reduce strength, it still can be beneficial in other applications as the construction industry, as it is constantly looking for new and innovative ways to improve performance and application, such as in the production of interlocking concrete blocks for wall partition. As limited review found on the use of recycling concrete aggregate for production of interlocking concrete block, hence the study investigated the behavior of the interlocking concrete blocks made from recycled concrete aggregate and loaded with flexural loading. So this is the main objective of the study, to study the behavior of one hollow interlocking concrete block made from recycled concrete aggregate under flexural loading. Okay, this is the composition of the material, okay, which consists of water, cement, sand, natural fine aggregate, sand or natural fine aggregate, recycled concrete aggregate, and super plasticizer. In this case, we use water cement ratio about 0.65. The mixture of the concrete was based on ratio 1:4 for cement, 1 for cement, and 4 for aggregate. So in this case, the natural fine aggregate was 50% and recycled aggregate about 50%. And then we added 1% of super plasticizer based on cement weight. And this one is gradation of the recycled concrete aggregate and sand. And this is preparation of recycled concrete aggregate. In this study, the waste material was tested cube that we collect from batching plant, which has the same range or the same grade of concrete, 25 to 30 megapascal. So this is dimension of the interlocking concrete block with a size of 390 millimeter length, 100 millimeter width, and 100 millimeter thick. If you refer to this one, the width of the groove is 30 millimeter, and then for the tongue also 30 millimeter. And then depth of this groove 15 millimeter, length for this tongue is 15 millimeter, and this one hollow is scattered at center of this interlocking block. Okay, so this one 3D for solid interlocking concrete blocks, and this one 3D for one hollow interlocking concrete blocks. So after all ingredient has been thoroughly mixed, the fresh mortar was poured into the formwork and compact to remove a pocket. The fresh mortar was then left to set for 24 hours, and the formwork was then removed. The cubes and interlocking blocks were then cured for 7, 14, and 28 days in a curing tank filled with water. The samples were cured to keep the mortar moist and prevent cracking. Once the curing process was completed for a given age, for the specific age 7, 14, and 28 days, then the specimen were tested. This is the formwork for the production of interlocking concrete block, okay? And then this one, the concrete mix was poured into the formwork for production of one hollow. And this one is hardened one hollow interlocking block. This one hardened solid block, and this is production of solid blocks. Okay, this one is test setup of the interlocking concrete block. In this study, we put one LVDT or linear vertical displacement transducer at center of this interlocking block, and then the strain gauge was located at center at the other side of this interlocking block. So the effective length or span from support to another support is 270 millimeter, and this interlocking block has loaded with phase rate of 0.1 millimeter per minute. Okay, so numerical application using abacus for the static analysis of both solid and hollow concrete blocks. And then this one results and discussion. If you refer to this, this is result for compressive strength of cubes at 7 days, 14 days, and 28 days. We can see that the compressive strength of the cubes increase as the age increase. And then this one result for ultimate load and flexural strength of interlocking block for at 7, 14, and 28 days. This one graph for ultimate load versus age of interlocking block. From these figure tables and figure, we can conclude that we can summarize that the ultimate load increases with age, and then the ultimate load of the solid block is higher than that of the hollow block at all ages. The percentage difference at 28 days between a solid and one hollow interlocking block is 54%. And then this one result for flexural strength of interlocking block. So the flexural strength increase with age. We have similar finding for this flexural strength and versus age of interlocking block, where the strength of the solid block is higher than that of the hollow block at all ages. The strength of solid block is 5.33 Newton per square millimeter, and hollow block is 2.45 Newton per square millimeter at 28 days. Okay, why this happen? This is because the void in the middle of the block reduces the ultimate load and the strength of the block. This one is for why flexural strength for hollow block is lesser than solid block. The presence of voids, the presence of void in the hollow block reduces its overall stiffness and makes it more susceptible to bending under load. So this one is strain deflection relationship of interlocking block at 7, 14, and 28 days. So this one is maximum deflection, the maximum deflection. If you refer to this slide, you can see that the solid block has lesser maximum deflection compared to one hollow. For example, at 7 days for solid, the maximum deflection is 0.048 millimeter, and one hollow interlocking concrete block is 0.072 millimeter with a difference of 50 millimeter. And then at 14 days, okay, for solid is 0.097 millimeter. And then for one hollow is 0.142 millimeter. The difference at this age is 46%. And then the maximum deflection for solid at 28 days is 0.39 millimeter. One hollow interlocking block is 0.492 with the percentage difference of 26. Okay, so in this case, the interlocking block is higher than that of the solid interlocking block. This phenomenon indicates that the deflection, the maximum deflection, is due to the bending or sagging of the interlocking block under load, which is influenced by a variety of factors, okay, such as the material properties, geometry, and boundary condition of the blocks. Okay.
I am sorry, may I just stop you concerning time?
Okay, which is influenced the variety of factors such as the material properties, geometry and boundary condition of the block. The main difference between solid and hollow blocks lies in the geometry. And then I move to the next slide. Good. Okay. Okay, this one result for strain deflection relationship of interlocking block at 7, 14, and 28 days. And we found out that the maximum strain is inconsistent with respect to age. And the maximum strain in one hollow interlocking block is lower than that in a solid block. And this one, crack pattern and the simulation using abacus model, where the crack pattern of the interlocking block observed visually match with the displacement contour in the abacus model. This conclusion, the compressive strength of the cube made from 50% RCA and 50% sand increase as the cube age increased with the maximum strength of 34.54 megapascal at 28 days. And then the flexural strength of solid block and the hollow block with 50% RCA at 28 days is higher than at 7 and 14 days. And then the deflection of one hollow interlocking block is higher than of solid block with difference of 28%. The maximum strain in hollow block is lower than solid block, and then the crack of the interlocking block, concrete block, was found visually in the middle of the block and matched well with the displacement contour from the abacus model. Thank you.
Thank you very much.